So hello all, I'm Vedas Lanikar, currently robotics engineer at FlytBase, and along with Amok, will be going ahead with this session on how we build the whole AIR product in just 60 days. This session is not just about the prototype or another hack session like probably a cool hack that we built with AI, but rather it's more about how we ship the production level code into and deployed, and now it is in customers' hand, and customers are pretty much very happy about the solution that we have provided. So how this whole product was built by just two engineers without any other, by being full stack. So that is the question, and there are many misconceptions or questions that might arise whenever we try to develop anything with AI. Like, let's say, how do you trust AI with production grade code, right? Actually, we don't really trust AI. We test it, we verify it. Like, how do we do that? And that's going to be the part of this session. And another would be like, does AI hallucinate and generate unreliable code? Probably, if done the wrong way, it will do it. But how can we make it generate the reliable and scalable and such production grade codes? So that can be done using giving the proper context, right? So all of that will be part of this session. Let's move ahead with the first of all trying to understand what is the product, right? That's what we should understand first, so that you'll get better context on what was developed in this whole session. So first of all, the device is edge device. Edge device meaning we put it near the docking station, so it is connected to the docking station. It communicates with it, and we get all the real-time data or video, and we can do video processing inside of it. Let's say we want to add some more features like object detection could be there. There could be VLMs, vision language models, working inside of that AIR. So we require high computation, right? Robotics people might know that we require all of this high computation and real-time processing. That's why we keep this hardware near the docking station to do all of this encoding, decoding for video streaming and all that. So this is going to be part of AIR and all the services. So let's take a look at quick video of what AIR does at the end. Yeah, so you can see that this is in production. We are able to detect vehicles and people and many other classes as well, custom classes that are asked by customers as well. So it is able to process the video in real time and count the number of vehicles and many more such features, right? So yeah, let's move ahead with the flow. Now, if we were able to do this using manual, like pre-AI world, we used to do it like with these cycles, right? We have a PRD, then we have a design, then comes tech validation. It goes to developer sees it and then tells the again product manager that this might not work. We have done this POCs, this is the bottleneck, and then PM also re-engineers all those things and come back to developer. So this is kind of a loop that is happening manually. But what if we try to shift it in the AI native way? What if the PM AI becomes the PM for us, right? So how did we do it? That's going to be first part. So the whole journey over in this presentation will be like, first of all, we'll go with PRD and starting from hello.
Sorry. Wait, this real quick. I think your screen is not changing. Your slide is not changing. Can you just check?
Which slide it is right now? I mean,
it's manual or AI loops, but I think
yeah. No, I'm on this thing.
Okay, all right.
Yeah. So yeah, continuing with this, all of the flow of this whole presentation would be like going from PRD to how did we do the deployment and testing, all of that. So we'll go one by one. Let's start with the first, what if a developer could ideate? What if a developer could try, what if the PRDs are not no more required? Like, what do? We get the ideas, we get the problem statement. First of all, that customer is facing this issue or customer wants this feature, and how do we plan or create a solution around it, right? This can be brainstormed with AI. This can be, roadmapped with AI as well. And then developers can do the experiments as well, find out what are the bottlenecks, and again discuss ideas on the same with AI only, right? Then in that case, no PM syncs will be required anymore. Like we can do it like very quick. So let's move on, like how we did it when it comes to ideating. So let's go ahead first of all with the problem statement. So what problem statement here we tried solving, and how AI helped us to design the whole, let's say, a PRD of it, but in AI native way, not a document, rather a whole AI chat, which is there for us. And yeah, so the problem statement was thermal detections. We, as you know, that the AI is edge device. We have video processing going on. We get the IR data as well, infrared data, and what we have to do is we have to do thermal detections as well. So this was the problem statement given, and then there were many things, like there were multiple palettes of thermal, and we have to explain all of this context, give all of this context to AI. First of all, we did that this is the problem statement, and what I'm looking for is like, what is the current state of the art in the thermal detections? Tell me that. Should I focus on methods or should I focus on model training? That question, and all these questions I went through, and then most important thing, I asked it to be like a brainstorming partner, not just like a tool, but rather brainstorm with me, ask me questions like it asked me, like, you want to perform what kind of aerial platform it is a whether it is a drone or a satellite or what it is, or you want to detect vehicle, people, or all those questions it asked. I brainstormed, I answered, and then it gave me a detailed research report. So that's how I use GPT to get the current state of the art, or all the required research that was needed to me. So now I have the research, I have current state of the art, what models are actually available. Further going on, I again brainstorm, like I have this specific requirements. So this was very detailed report. And yeah, this was one tool that we used. Let me quickly show another tool that we use, which was Perplexity. So Perplexity is very good at going and searching web and do all of this was done in deep research, by the way, in GPT and Perplexity both. So yeah, we got all the information or research. Now after this, what PM faces is that how do we just validate that every research that we have done, every solution that we have found will work and will surely work. And that's where the developer part comes in, right? Now the AI has played its role as probably a PM. Now how should I validate that whatever the AI has done is right, and we can quickly do the POCs and again look back to AI and tell AI that this might not work because of this reason. So I came back to Windsurf. This is Windsurf, where we can uh, just code in real time and then observe what all our POC analysis is. So one of the problem that we were facing over here is, like, in thermal there are different temperature ranges and all that. So I needed to analyze it, that why a model might work in this case and might not work in this case. So I asked it to write some code, do some image analysis. It wrote the whole code over here. You can see I verified it, and then I asked it to run, and I got all the results, like what are the differences in, let's say, two images. Okay, I'll asked it to plot graphs and give me all the required results, and this gave me insights on what is working and what is not working. So I again went back to GPT. So I told the GPT that yeah, these solutions are not working. I tried, I tried training a model with mix of RGB thermal, it's better, and all of this communication was going on. So as you can see that we have came up with a solution, and now we have tested we have done all other POCs as well. Now comes the part of architecture. Okay, so the planning is
just
yeah.
Before we move on to the next segment, an interesting point over there that I wanted to just highlight is how from the problem statement to working POCs is all a single loop, right? You don't kind of break it in between where you kind of have a separate team or separate people working on the research part and then separate people doing POCs and having multiple back and forth. So in the product like AIR, there is a lot of research involved, like drones with real-time video and a lot of analysis on that. You won't necessarily find very simple state of the art approaches on the internet, and that is where with all of this deep research, I just quickly saw that there was a question there also around how do you trust it, right? You don't trust it blindly, but because you can quickly iterate and do POCs on the approach that AI is suggesting. If AI is taking you 80% there, you can quickly validate all of those different 80% approaches that it is suggesting, and that is much faster than in a pre-AI era where you would like manually go through these papers or things like that. So in a pre-AI era, you had to take every step very carefully. This is kind of a playground where you can quickly evaluate a lot of different approaches. You still might get 90% of them don't work, but reaching to that 10% is much faster. And that is what Vedas was showing, and he has been able to achieve by quickly not only going through deep research, but also doing quick POCs of the different approaches that have come out.
Right, true. So, as Amok said that we have now validated it by doing POCs. The next task comes is to architect it, right? Not now. This was more about solution. What solution we are trying to provide, but now how to convert this into a language for, let's say, Windsurf or Cloud Code, which tools we use for coding, and tell them in a better way what needs to be developed, what solution we are trying to write, right, in the coding. So for that purpose, we need to better architect it, and that's where comes the Claude. So let's hop into this. Now this is another service. Okay, this is another example, not related to thermal, but this is a service that we were trying to write. This was more about debugging, or this was more about recording. So what it does is it gets the live video feed from drone and it records it. It maintains the storage, like when to up and then upload the all the data to cloud. So all that was the task for the this service. So I have given, you can see that specific requirements over here. I want to architect this. I don't want to code in this chat. Okay. So I have given all the flow. Like this will be a separate service. There should be a data management. I gave all the requirements that were there in my mind. Okay. And now I kept some open-ended questions for the AI as well, like scheduled S3 uploads. What kind of schedule? Can you give an example, like how you are thinking about it? Whenever we try to validate what AI is trying to understand, ask it questions like, can you give me an example of how S3 upload would work? Then AI will, give it. So there is much more, control over AI and control over what AI is understanding. So that happens over here, and we also get more ideas on this. So I have kept some open-ended questions over here. I have also given like, make sure not to increase the scope. We have to build this in 10 hours. This service hole was built in 1 day only, and I purposefully gave this that we have to build this in 10 hours because whenever you tell something like this, or if you tell like, do this and I'll give you $100, it performs like way better. So this was done purposefully, and then just do not write any code, just architect it, and it gave me a first draft. So we have a first draft, which is like pretty much all of the things are here. So first of all, I try to explain what here we are trying to achieve in this stage. In this stage, we are trying to achieve like the document that we require for coding, the architecture diagram that we require for coding, and all that context which we can pass on to our another coding agent, probably Cloud Code or Windsurf, which they'll use these documents and create those services, right? That's what we are trying to create over here. So I've went on the conversation. I gave more context. I asked it to draw a better diagram, and after I'll show the final outputs, what were the final outputs. And you can see that after giving a lot of context, yeah. So we have a document over here. So it has created the complete document, what this service will look like and what all parts will be there inside this service, what even the directory structure would look like. All of that is there. And another is the diagram. So we can use this diagram to communicate between teams, between AIs, and that can be done using this diagram. And later on, I'll show you how all of this will help. So as you can see at this step, we have architected the complete microservice using Claude. So the architecture is done, and now the part comes is coding, right? So as I already said, it requires a proper context. All that matters is how we give the context. Now the question comes like, how should we give the context? Should we mention everything that AI is supposed to, use OOP or use solid principles, all of that? And how should we structure all of that? That question remains. And how do we increase the reusability of that? Like AI needs to use solid principles is going to be there in all the services that we are going to build. So how did we solve this problem for every other service, and how we scaled through the documentation structure? And not just that, but now here AI does the complete routing as well. I'll explain what is routing in a bit. So as you can see, we have a docs folder. I hope this is visible. I'll zoom in. Yeah. So we have a docs folder. You can see that this is the structure of our doc. This is part of any repo that we have. We have kept it common, and this document structure has specific directories. Common is there, modules is there. So common is like for basic coding guidelines. You can check like coding guidelines, what coding guidelines are there, all the principles that it needs to use, and how like Python specific things, C++ specific things, and AI agent code modification guidelines. If it is going to modify, what all things it needs to follow. All of these prompts are given here, and which we can reuse later on while creating any other service. Yeah.
Right. If I can just interject here with us in interest of time. So on a high level, what we do here is we ground the coding agent, whether be it Claude Code or Windsurf or any other agent, on multiple levels. Like grounding is done based on high level best practices. Grounding is done based on the expectations from each of the individual services, which is mostly covered in the module section and the clusters section. Then from operations, you have common themes like logging, monitoring, and how those things are supposed to work. And then in terms of references, you also get a high level thing. In terms of operations, again, CI/CD, how the deployment works. So now AI gets context on multiple levels on how it's supposed to write code, what the different services are supposed to do, how they are internally architected, what are common kind of shared abilities, etc. And with all of this context, now when kind of we inject the new requirement, it is able to perform in a much more grounded way than without having all of this context. So this is how kind of the journey takes us from high level product requirement to kind of what the problems users are facing, to research, to generating architecture for each of these services, seeing how it will integrate in AIR, and then finally developing code. Next, in terms of the step that comes is, how do you evaluate all of this code that AI has written? You see, AI is pretty fast. It will write kind of thousands of lines and hundreds of files in an hour. But now evaluating that, making sure that all of that is actually production grade. And that is where we are using AI to generate unit tests as well as E2E testing pipelines for the entire product, where once AI has generated all of these services and code, the entire system is just got up and it is run through this entire testing cycle. And that is where we kind of generate confidence on the services and code that AI has written, that, okay, this is production grade. It is passing all of our unit tests that we have. So where we spend a lot of our time is validating unit tests, when validating end-to-end tests and seeing that, okay, it's covered all the flows that we need the product to cover, and less into actual code review. Code review is again done on a code quality standpoint, but a lot of functional loops are closed through unit testing and E2E testing. So I'll just present my screen and show a demo of how we got unit tests and end-to-end tests working with AI. and how that works for our product. So yeah, is my screen visible?
Yeah.
So this is where I have the current our demo unit already set up and running. And now if I just run this, what you'll see is this starts setting up all the different services needed for end-to-end tests. It will publish a fake video, like we get video from drones. It will verify whether things are working, not working, whether we are getting detections or not, so on and so forth. And this is a complete automated system. So what I normally do in the morning is just to do a quick sanity. I'll up everything, I'll run this and go for coffee. And in the end, all I get is a clear test of what has succeeded, what has failed, what's going on. And that kind of sets up the rest of the day. What we also do is for individual services, we have detailed unit tests. So as you can see here, okay, a couple of tests are failing. So probably next release, something has to fix. So with all of this, we get very clear and detailed reports of kind of what's failing on a service level and what's failing on an overall system level. And with that, then we are able to close the entire loop. So with us, if we can quickly show it. All right. So with this, as we close the entire loop, now we see okay how we are going from PID all the way to tests and a working kind of production ready system. And with this now, in terms of next steps, what we are looking at now is to actually close this entire loop, how we can kind of feed all of these test results back to the coding agent, back to the architecture agent, and see if the architecture agent is able to figure out, okay, there are some issues that need to be fixed. The coding agent is able to figure out low-level bugs and solve those. So that is kind of more in the future direction of what we are looking at. Yeah, let's see if we can present the screen again. So yeah, on a high level, again, what we are looking at across the entire pipeline is for PID and tech validation. This is again where devs themselves are doing prioritization, understanding trade-offs, and kind of a PM style planning. So GPT-4, Claude, all the different LLMs come in handy over here. This then follows into architecture design. So once you have a high level initial brainstorming done and high level POCs completed, this is where we kind of figure out how it will fit into the entire current code base of the product. Then package all of that into context for either Windsurf or Cloud Code or these different coding agents, run through code development, and then in parallel, we generate test cases, generate end-to-end test cases and workflows so that all of this can then be evaluated much quicker than any kind of a human would sit and read through code and evaluate. So yeah, kind of high level, these are the different development stages and how kind of we are using AI in each of these stage to either generate it or kind of brainstorm as a development partner and accelerate each of these phases. Yeah, I think on a high level, that's it from me and Vedas. Any questions? We'll be happy to take those.
Awesome. Thank you. Yeah, thank you so much, Amog and Vedas. I think appreciations and celebrations are already on the way in chat. Harshal and Mohit are suggesting that it's an excellent boilerplate structure. And Mohit asked if all of this is open source. So Mohit, yes, we are building everything in public and we try to share as much as we can. And please sign up for our calendar to be here every Thursday. New hacks every Thursday, right? There's more on why we are doing this, why we are sharing our AI playbook. I've just sent a link to our manifesto. Thank you, Tushar, so much. Arsha has once again sent the link to our WhatsApp group, guys. We are sharing of all of our latest updates and news that we are coming across in this group. So please do stay connected here. And we have a couple of more minutes. If anybody has any questions for Vedas and Amog, we'd be really happy to take them.
Hi guys, can you guys hear me? Rahul here.
Yeah, hi Rahul.
So this is amazing work, and I'm sure you're feeling very happy about
Very
all of that. And it's definitely a great achievement, something that is really highly looked upon in terms of where we want to go, right? So given all of this work done and everything that is demoed, right?
yeah.
Um, Questions and very banal basic questions, right? So when the code is developed by the AI,
Yes.
and I'm also developing something for myself, right? So that's why I'm asking this. So I'm facing some issues. So what happens generally is it gives you a an outline of the code, which is with assumed variables in it, assumed line items, and assumed placeholders for certain sections, right?
Yes.
So when you do this, and when there is this folder structure developed and put up by AI, right? Generally, what happens is when you're interacting with multiple LLMs, and when you're trying to pass on information from one LLM to the other to make sure that they are in sync and they are talking to each other and they understand what is being done, right?
Yeah.
My observation is they try to overstep each other. That's one. Second is a lot of effort goes into really validating and optimizing the code just to make sure that the design objective stands correct.
Yeah.
Yeah.
Uh,
Now, given that happens, what happens, and in my experience, what has happened to me is I literally try to do some small development, and that was just to experience what are the challenges that I face, because I work in a project management field, managing big work, but I feel but the team constantly keeps on struggling on doing this iterative work, which is validating a lot of stuff, right? How did you
right.
come across, how did you overcome that, and what is the best way you thought is the right way to overcome this?
Understood. Yeah. So a couple of points here. Firstly, what in our experience, definitely the documentation and as much as details can be added to that documentation, that helps the AI to remain grounded. So you will
Mhm.
see less instances of it assuming things. If there is enough in that documentation where kind of it has all the details over there, there's less room for it to start assuming. If the requirement itself is pretty vague, especially
Mhm.
at the coding level, then it will start to assume things. Secondly, yes, what you mentioned, we did face those issues where we had to chuck out entire services that we built with AI. The
Absolutely.
thing is, it
Yeah.
is difficult from a uh, mindset standpoint because pre-AI, this used to be a huge mental burden, right? You build something pre-AI, all of this used to take, let's say, a month to build, or let's say 3 weeks to build a service. And at the end of 3 weeks, if you have to chuck it out, that's mentally taxing. But what
Mhm.
we have to remember with AI is it is taking you 80% there in a matter of minutes.
Mhm.
So kind of in the last 2 months, over 60 days, what my biggest learning has been, I have become very open to checking things out. I build
Mhm.
it with AI. If there is something that seems okay, fixing this would be too taxing, rather I would like to start from scratch, I just check it out, start again from scratch, and
Oh,
that's much
you've done
faster.
that. Very nice. I've done that too.
So
So that's why.
yeah, so
Great.
what you faced, right, where AI generated something which you can't really fix now, or it doesn't meet,
Mhm.
yeah, you have to be mentally accepting, and that kind of needs a mindset shift to kind of just like, okay, let's just tug this out, we'll start again, because the loop itself is pretty quick now. In a matter of a day or so at max, we'll again be at 80%.
So the
So
other thing is, tell me how much of whiteboard did you use? So defining a project objective, trying to understand what all we can achieve in getting the product right, trying to achieve what all features we can add, etc., etc. through AI is good, right?
yeah,
Now, when we have all of it listed and the project objective is defined, potentially you can go to the lowest level of identifying the variables of it and try to define more on it using AI, right? At some
yeah,
point in time, I felt that there is a need of getting all of it, putting on a whiteboard, ensuring that the pieces match, and then getting back from the bed black from the whiteboard back into AI, ensuring that all my pieces are there and coding is exactly appropriate as per the objective defined, is something that was critically missing in the way I approached it.
So what we do is we definitely have a lot of stuff on whiteboards, different tools where we have just architected, okay, on a high level, based on this problem, what are the different services, what would its service do, so on and so forth. And for that also, what we do is we normally have a lot of verbal discussions, which we just have one of the note takers or something just continuously documenting. So if both of us are, let's say, having a 2-hour discussion on different services, we just have a note taker documented, and then these tools are fairly, you have a good enough summary, you feed it into GPT or some other tool, and it is able to generate a decent layout of what was being discussed over 2 hours. So we do that, iterate over that. So that keeps us grounded as to where we want to go. And then individual services are then picked up, and then what Vedas initially showed, we take it to that through that cycle.
Yeah, so that is exactly what I was trying to solve for, right? So when my primary question is now coming up. So what happened in my case is I am developing something. What I did is I asked ChatGPT to give me a good structured or design objective with good structured design element that I need to cover for. And then I asked ChatGPT to put up a list of all the to-do activities. And it did put up. And what happened is the second LLM that I used, I basically asked the second LLM to read that list and start developing accordingly, right? Now, once the second LLM did that, I basically asked the second LLM to also document everything that it developed, generating a third file. And I asked the ChatGPT to look at the third file and then go and update the first file.
Right.
And
So, Rahul, I think all of these approaches work. There's different ways you can approach it. What I think just works is to keep that in mind. The more higher level work that you are doing, in terms of where there is more chaos, there is less understanding of what needs to be built, how it would exactly be built. That is where more humans are in the loop, and you have to leverage AI for research, leverage AI for those things. As soon as you start to figure things out and okay, it becomes more structured, you can leave a lot more to AI. So I think that's from a high level what I can share. Again, different ways you can do it, either through diagrams or through documentation and so on and so forth. So we spend a lot of our time on those levels, discussing architecture, discussing okay, which service needs to do what and how. Lower level details, majorly, once you have it well ironed out, AI is able to do it. If you don't iron it out well, then kind of the frustration happens and you have to chuck things again and again. So whenever we have to chuck a service or redo, we first again think, okay, where is the context missing? What did we not share? So you kind of go back to that drawing board.
Great, amazing.
And just to share, we have had our fair share of services and huge chunks of code that we have to chuck out in this. So it's not like, okay, you just get through this and in a day or in 2 days, you have all of this working. There's a lot of back and forth that you have to do.
Perfect. I'll let the other team.
Question.
Yes, thank you, Amog and Vedas, for the insightful presentation. It is a good end-to-end framework that you have created. I just had 2 questions and 1 experience to share. One question is how much of this is like AI agent and automation, like end-to-end, in a way that flows automatically. And second, have you tried debugging? I'll just share a bit of experience on debugging using LLMs. So,
all right, I'll quickly share answer to the first one. We aren't really closing a lot of these loops between agents right now. We are still kind of figuring out, okay, what are the best system prompts, what kind of context works where this loop can actually close. So this is kind of in coming couple of weeks where we want to get to. But what we've kind of figured out is, okay, where are the different places where AI is able to accelerate, and even manually closing the loop, we are able to get things done much faster. So that's where we are. Definitely one of the next things that we want to do is see how we can actually close all of these loops and have AI feedback back to itself. So a short answer to your question is not a lot of this is AI agents which automatically close the loop, but again, we are reaching there.
Okay. So my experience with debugging was that I had cloned a library, a repository from GitHub, and I wanted to make it run. And usually, what happens with repositories, as you know, either they become outdated, so the libraries or packages that they use become deprecated, or they are upgraded, so therefore they don't run. Or there are also some cases where people don't want, people who publish papers, they kind of just to have accompanying Git repo, they upload it, but they don't make sure that it is completely in a reproducible state. So
Yeah.
these kind of things. So when we want to implement or execute, reproduce their results, it becomes really difficult. And in one of such cases, I was debugging for almost 3-4 days with Gemini, and we tried. I mean, there was a point in time when Gemini also gave up. Like, now there's nothing more we can do. But just day before yesterday, I was creating a knowledge graph. There also it gave up. Kind of, okay, there's nothing more we can do on this. And then I kind of came up with certain ideas. If I, one idea was for the knowledge graph, I'll share. One idea there was, instead of concatenating all the documents, I had 11 documents, and concatenated into a single document. So when we created separate knowledge graphs from these 11 documents, I asked the Gemini LLM if we can create it using separate documents, and would it work? And it said that it is a good idea to try. We haven't tried that, and fortunately it worked.
Yeah.
Secondly, in the Git repo case, it was like it had suggested 4-5 methods, and in one of those methods, it had told me that, why don't you kind of try making the NVIDIA compiler change to 17 C++ instead of 14 version, and that also worked. So I mean, it took me 3-4 days in the Git repo. It worked. In the knowledge graph, it was me who suggested, and it said that it was a good idea. So it is kind of a combination.
Right. Absolutely. That is what our experience has also been. That a lot of times, as devs or as developers, we want to understand what these things are and where AI is getting its information from, etc. There's always that curiosity. But what I have seen is, at times, it is best to discuss with AI like a partner, brainstorm with AI, and let it also suggest, and that's where you can get breakthroughs.
Yes.
It might not work always, like in your case, it probably worked for one of those scenarios, but yeah, it's a kind of low risk chance that you have to take in these cases.
Absolutely. Yes. Thank you again.
Yeah.
So one more question in chat.
Yeah, Harshal had a question. Okay, not a question. I think he's just sharing his takeaway, and kind of that is what has been kind of my takeaway as well in my experience last couple of months, is that it is so quick, so easy to kind of with AI get up to 80%, get up to 90% of the production level of any feature or any product that you're building. That is just very easy to just quickly iterate, check out, iterate again, and get it to work. Yes, Gautam, please go ahead.
Hi, Amok. So I just have a question. Am I audible?
Yes.
So I just have a question. You had shared the information of testing, okay, at the last. Yeah. So I have a question did you used automation framework here, or you have used only the UI tools there?
No, so with AIR, what we have is we have our own custom kind of framework that we implemented.
Okay.
That is because we need a lot of orchestration between different services. So at one point, what we also do is we manually kill a few services and see what's happening and things like that. So it's kind of a bit of chaos testing, bit of E2E workflows, etc. So, and with the kind of context that we already had generated through different docs, it felt quicker to just have AI build a straightforward framework with PyTest rather than looking for something to orchestrate as of right now. In the future, yes, as we scale these tests, we need to look for a framework. And yeah, again, the thing is that with AI, all of these decisions have now become kind of two-way door decisions for us. So we don't really need to take it right now. We just kind of AI can just redo all of this with the framework that kind of if we need it down the line.
Yeah.
Okay.
Thank you, Amol. Good job.
Thank you.
Thank you.
All right, I think we are a little over time, but okay, Aman, I think has another question. Amog, if you're able to take it.
Hey guys, am I audible? Yeah, so
Yes.
great job, guys. I think it covered a lot of questions, at least queries and questions, at least what I had in my mind for the last, for a long period of time as a PM, like struggling on a lot of these LLM models, trying out different things. So one thing that I have struggled, or at least I'm still trying to figure out, is that while dividing at least a broader requirement into multiple small tasks and then going deep into each of those tasks through any of the LLM model, once you go deep dive, like if I can take a tree structure, once I'm going level by level deep into for one particular task for a requirement, and then like it gives me that level of depth. But once I'm coming back and syncing it to another parallel branch of it, that is at that point of time, I've found that, like, especially with ChatGPT and some of the other LLM models, like it struggles to keep it in sync with my other branches. For example, there's task 1, task 2, task 3. I'm leaving from task 1 depth I've completed, and I'm coming back to task 2, which there's certain synchronization that it needs to have with the first level of depth. So that is something where it struggles. Like I have to chuck out a lot of second level of queries that I'm putting in, and there's a lot of synchronization issues. So how can we handle it?
You just don't do it in a single chat. So what you do is you have 3 separate chats which are each going in depth of task 1, task 2, task 3, and you have a separate high-level thread which is generating interfaces between the 3 tasks. Okay, so task 1 is supposed to on a high level output this, which is an input to task 2, which is supposed to do this, which is an input to task 3. So this is the information or common interface that is shared by all 3 of, let's say, chat threads of GPT or something like that. And then you go deep into each. So while each has a high level context of what the system is going to look like, it can then go deep into one, and you can just end the thread there once you're satisfied with what you needed from that thread. Again, to share between context, it's good to generate a high level summary of that thread. So it again knows, okay, based on this research, so this is the interface level change that has happened. And you share just that with the rest of the threads. And that is how kind of, it's like similar to working with different teams. You wouldn't really have each teams go into depth of each other's work, right? You would interface through APIs or interface through kind of high-level documents. So that's how it's supposed to work with AI.
Or adding on to the same, like you can maintain a project structure in Claude or GPT, where you can keep all those chats going on, and also maintain a high-level documentation over there, which other chats can also follow. So that can be another solution to it.
Great, thanks guys. Something I can try out on my end and see if that helps. Thanks guys.
Yeah, great.
Awesome. I think little over time, but I think we addressed some really, really important questions. So thank you so much, Amog and Vedas, for giving this time of yours. And thank you so much, everybody, for participating and for asking such impactful questions. More such questions, discussions to be continued on our WhatsApp community. Please do join in.